Consider this. What if a computer could learn? Have you ever wondered how your phone knows your face? Or how a website can translate a whole sentence from one language to another in the blink of an eye? It's not magic, it's science. Specifically, it's a very cool and powerful tool called a neural network. Now, what if I told you that this tool was inspired by the most amazing computer we know of, the human brain? That's right. We're talking about building a program that doesn't just follow a strict list of commands, but one that can actually learn from experience and find patterns and make its own decisions. This isn't science fiction. It's happening right now, and it's changing our world in incredible ways. Let's dive in. At its heart, a neural network is a way of teaching a computer to solve very hard problems. Instead of writing out millions of rules, like if you see a pointy ear, it might be a cat, we let the computer figure out the rules for itself. We do this by showing it lots of examples. Imagine trying to teach a toddler what a cat is. You wouldn't give them a textbook definition. You would point and say, "That's a cat," over and over again with different cats. Neural networks learn in a very similar way. They look at data, make a guess, learn from their mistakes, and slowly but surely get better at the task we've given them. This ability to learn from examples is what makes neural networks so important. They are the engine behind many of the smart technologies we use every day. They help us see things in medical scans that a human doctor might miss. They help us hear our voice commands and turn them into actions. They even help scientists discover new stars and galaxies by sifting through massive amounts of telescope data. Understanding how they work is like getting a peek under the hood of the future. It's a journey into how we are teaching machines to perceive the world, and in doing so, we often learn more about how we perceive it too. So, how does a computer program think or learn without a brain? It all starts with a simple idea, a basic building block that, when you put enough of them together, can do some truly remarkable things. It's not about one super genius part, but about a team of many simple parts all working together. Think of it like a colony of ants. A single ant isn't very smart, but together, the entire colony can build complex tunnels, find food, and defend their home. Neural networks harness this power of teamwork, but with numbers and data instead of ants and dirt. Let's get to the building blocks. To understand a neural network, let's start with a single, artificial neuron. Think of it as a tiny gatekeeper. It receives information as numbers, does a little math, and decides if that info is important enough to pass along. So, what is this math? Well, each connection into the neuron has a weight. You can think of a weight as a volume knob. A high weight means the information is turned up loud. It's very important. A low weight means it's quiet. The neuron adds up all this weighted information. If the total sum is bigger than a certain threshold, the neuron fires and sends its own signal forward. If not, it stays quiet. To build a neural network, we organize neurons into layers. The first is the input layer, where raw data comes in. For a cat photo, each input neuron might see 1 pixel. Next are hidden layers, where the real processing happens. Early layers spot simple things like edges or colors. Later layers combine those into more complex shapes, like an ear or a whisker. Finally, the output layer gives the final answer. For our network, it might have 2 neurons, one for cat, one for not cat. The highest activation is the network's best guess. But when you first build a network, its connections are random. It knows nothing. Show it a cat, it just guesses. This is where training begins. We show it thousands of examples, and after each guess, we calculate how wrong it was. Then, we nudge the connections in the right direction, again and again. It learns by making and correcting millions of mistakes. Let's zoom out. Neural networks find patterns in data. Inspired by the brain, they're teams of simple digital neurons stacked in layers. They learn from examples, make a guess, get feedback, adjust their weights. They're powerful, but limited by training data and bias. So we ask, is it fair? safe, reliable. Even now, they help doctors optimize energy and explore space. Think of them as microscopes for patterns, tools that augment us, not minds. Try a tiny classifier, tweak it, watch it learn, and see mistakes. In short, neural networks learn from examples to spot patterns. They're tools that help us, not replace us. Thanks for watching. Subscribe to Tech Protocol Lab for more beginner-friendly AI videos. See you in the next one.